I've just started my, I've made my move, and I've started my PhD and everything, so I've got a bit of time to stream now, so I'm back on the old computer grind. Now, the last thing I remember was the Redstone multiplication circuit. I was just finishing this up, right? I was I guess blue wool will do just fine. Clearly I haven't got a stable keyboard set up, so you're going to see me struggling to play the game for a bit. So yes, finishing up the redstone multiplication circuit. I remember I switched over to this side because it was going to save about 3 seconds, I think. Essentially having, because this is the circuit that's, as this circuit can propagate, this signal can propagate through this very slow circuit here, while the second number is being loaded, so basically it's free to get through all of these normal repeaters. And then this pathway over here is much faster because it's the glitched instant repeaters. So this side is almost instant. So what happens is the first number to get multiplied comes in, gets stored in here, then propagated through here, slowly along here. And while it's propagating along here, CPU cycles to the next instruction. And technically the next instruction does not have to be a multiplication instruction, but it probably actually, no, it doesn't need to be a multiplication instruction. But if it is the multiplication instruction, it then sends another number which will go through here almost instantly, and it will open up this side, doing the whole bit shift thing, sending it into the summation unit. I've moved from one loud and noisy high street to another loud and noisy high street. So just need to connect up this side. And basically this side can be, well, not quite as slow as it likes, but nearly as slow as it likes, because it's just waiting. It's just passively percolating through the system while the CPU cycles. Propagating, not percolating. I mean, loosely speaking, it is percolating too, but it's a trivial case of percolation. Yep. high street. It's too warm to close the windows as well. Right, so those, this one here is those are connected. Okay, so it looks like these are all connected, except this one. So, oh, sorry, some nausea. So that side is now connected to that, which is what it needs to be. This side just needs to be generically plugged in. Well, actually, it needs to be insta-wired, which is rather irritating. You know the routine of building these insta-wires at this point. So get rid of that. Right, so the bring this over here, straighten this out if possible. I'll have to do a slight bottleneck. It'll have to be constricted to get past this. Also, where the devil is the output going? To remind myself how the output works on these things. Oh gosh, it's even louder than my last house at High Street. At least I'm not living opposite a pub. Right, so the output is stored in this thing, right? Yes. So output will come out here. That's simple. That's easy. You don't need to worry about that. It's all this that I need to worry about. I think it unavoidably there's going to have to be at least one regular repeater in somewhere around here. So I'm going to have to zip them all together to get them around this guy. Yes, I've moved to somewhere significantly less rural than my last place. So, I mean, I'm assuming you can hear all the traffic noise on stream. Like, if it's not coming through on the audio right now, there's like buses driving past. If there's an ambulance, there's like a bunch of loud cars. Um, and I apologise for that, but it is what it is. Yeah, if I can shut the windows, it will start to get temperature in here will go up to about 25 degrees, which is incompatible with me being alive. So I've got to keep the windows open. It's probably actually another one of those streams where the audio isn't even on. But I start to I'm only really comfortable in a flat that's colder than sort of 16 degrees. So the place I'm in right now is extremely well insulated on the walls. And, clearly people are running a lot of heating downstairs, so it's very uncomfortable for me. It's because I do all the ice water swimming. It's like my body is just adapted to being at much colder temperatures. Oh, that's funny. I think I nearly overheated the gym ice pool the other day. So I was sitting. So you go to some gyms have like a spa, and they have like a hot. It's not a hot tub; it's a cold tub essentially. It's a tub with refrigerated water at like anywhere from like 20 degrees or whatever down to like 0 degrees. Anyway, I was sitting in one that was supposed to be at 5 degrees, right? Um, and I was in there for about 35 minutes. By the time I got out because well, firstly the fan started running like extremely strongly on the cold pool, right? Like it was really gasping for air, trying to cool itself down, and then it started beeping, and the fan was going even stronger. So I was like, if I stay in, I might actually overheat this poor thing. Uh, I got out and the temperature had gone up by like a degree or two. Well, the temperature was still up by a degree about 15 minutes after I got out, so it must have gone up like 1 to 2 degrees. I don't know. But anyway, I'm quite proud of the fact that I might have plausibly been on the verge of overheating a cold pool. I got out of the cold pool. It was at 6 degrees, and then spent the next 15 minutes in the cold pool at 10 degrees. It's like during that time, it's like the poor old cold pool that was at 6 degrees was like huffing and puffing, trying to get back down to temperature. spent 10 minutes on a stair machine to warm up. Actually, I nearly had a heart attack on the stair machine. It's like all of my blood was like in the wrong place, and I just hopped on the stair machine and like put the intensity way up. It's like I was extremely dizzy when I got off. Do some benchmarking, see what my performance on a stair machine is when I'm not super hypothermic. Although admittedly I wasn't super hypothermic, I didn't even go to after drop. But after 10 minutes on the stair machine I was basically warm. Whew. Does make me wonder, can I put out more BTUs of heat? And I think BTUs is the correct term. And like a refrigeration unit can suck up. For those of you who don't know the law, when I'm not dossing around playing Minecraft, I do a lot of ice swimming. So that's the context for this otherwise rather bizarre conversation. Oh, that's right, this needs to be the address bus. In fairness, I could move this whole thing over. Might be the right idea. If I move this over by a few. If I can remember the button for inventory, that would help. It's not I, it's not U, is it J? H? Oh, it's E. Huh? So I continue to be inactive Minecraft. here. That's the address control unit. That should be okay. Yes, that's all good then. That just means I can concatenate everything at this end. So slide it all together. Yeah, technically I'm being somewhat lazy by training in a gym cold pool. I should be up in the loch doing actual distance swimming, but my car is currently pumping out an enormous amount of carbon monoxide and worse, so can't really get up to the loch right now. Gotta get that fixed urgently. Also, the gym cold pool is currently a lot colder than the loch. Of course, not actually getting any exercise in the cold pool. So this bus is pretty much all ready to plumb in. Oh, hang on, that's right. There needs to be a switch. Switch with this guy. Oops, that was a mistake. So it needs to be something like this. Connects over here, plumbs it in like that, and then there's a switch somewhere around here. Right, so switch. How do these switches generally work? So firstly, have I routed this correct? Have I routed? I need to route a bridge over here. Time to play a little bit of Minecraft with this. quite proud of this whole computer. It's nice when you plan something and it works. I spend a lot of time doing things that aren't technically possible, or generally nobody knows if it's possible or not. And then like this project, because it's just a computer. It's known that you can build a computer. Therefore, it's like an easy victory, is what I'm saying. It's like if anybody can build a computer, it's me. Given that people do build computers, that means that I can build computers successfully. Which basically means all I have to do is play a bit of Minecraft, a couple of hours a week, keep building it, and eventually I'll have a functional computer. Essentially, it's an easy victory. I spent a lot of time working on essentially things that are unquantifiably difficult, or so it's nice to have something that's, in the words of Todd Howard, just works. So anyway, the switch, which we completely failed. When I'm done, the CPU is just not going to be timed correct. To be fair, timing the CPU is going to be an absolute nightmare. But I don't know how I'm doing that yet. But yes, it still could fail, I guess. That's what I'm saying. Anyway, so this is the switching signal. I need to try and remember how it works. So it needs to have a read signal, a write signal. Essentially, the write signal needs to be on always. So just get rid of that. That there. So it's always going to be outputting a number there. Which means that this can just feed straight into the read signal. Sorry, this is the write signal, that's the read signal. It's always confusing because obviously it's contextually dependent which side is read and write. Because obviously this side is reading from that and writing to that. So if I'm talking in the context of this is the read side. If I'm talking in the context of this is the write side. And obviously I'm talking in the context of the bit storage, so yes, it's the write side, and this is the read side. This needs to be triggered on phase 1. So it needs to be a NOT gate. Where's the output is over here. So what state is this currently in? It's currently in a broken state by the looks of it. This thing only three phase. It is so it needs phase 1 is write to that, phase 2 is write to the other side, then phase 3 is read from the device. So read from the chip rather. So it only needs 3 phases. These things are kind of a nightmare, let's be honest. So that should put it into the ground state. So it's in the ground state. Ground state, lol. Quantum field theory. Yeah, so that's in the correct state. Now, if I turn that off, it should stay in that state, right? Yes, that may not be ideal, but now if I switch it back on, oh right, I've broken it. That wasn't the right side to put the signal into, was it? Which side? Where does the signal go in? Oh, this is confusing me. Either way, this is kind of broken right now. So I need to understand why this is turned on. Unfortunately, I was born stupid. I believe that the correct side to turn on is actually this one here. Yes. Um, so there is that small issue. I need to remember why that is. So it's not supposed to. So the bottom switch is not supposed to switch back on. It's supposed to stay on. It's supposed to repeat, but it's not supposed to switch back on when it cycles like that. It's supposed to. Basically, this should be off while this one is on. So it sends. So it sends signal down here. Now this signal is. Oh, that's right. That is right. I had to hack it because the Yes, I had to hack that. That's why. Because of the geometry of the thing, I had to hack it to put that signal and double it up with the other one from the bottom one. That's why that is. Now I'm thinking a little bit and trying to figure out if that's going to seriously break the computer. Um, I think it shouldn't matter. But it could marginally slow down operate. Well, no, it won't because it's always going to cycle this way, whatever happens. I also feel like I had a way of fixing that, but I can't remember. So the problem essentially is that this signal has to come in on this side to get to that switch there, right? But to get the other signal out here, the signal from that has to go across as well. But obviously, because it's one layer, you can't. So you have to. Now I could instead plumb that signal out the side here, because that signal's supposed to be coming through that one there, right? So I could redirect it here, which might make sense. Because of the routing anyway. So if I, obviously it's useful to have the clocks all in the same place because it keeps the output succinct. Now, what was the other problem? The other problem is that cycling it. So cycling it like this sends it into that state and that state, which is good, right? Because now it's going to be switching into that there. Now the problem is, so if we imagine that there's a bunch of data coming down these buses, right? When this is initialized to a number, we want that number to end up in here. When this is initialized to zeros, we want it to not end up in there. But when now the switch that essentially opens this up here is tied to that there, this signal here. Now, of course, when the data bus is set to 0, this also gets set to 0, right? The problem is that this signal here stays on, which means this side will stay open, this will stay open, and then zeros will be read to here. Which is unfortunate. I'm trying to think how I got around this with the binary. Let's see what I did with the binary adder. So or the binary comparator for that matter should work. Unless it's also broken over here. Oh, that's right. That's easy to fix. It's very easy to fix. So you just need to put in an AND gate with the address controller, and that will switch it on or off. Essentially, just loop the address thing around here, put an AND gate there, and then when the address is not toggled on, this will toggle off. That's fine. I'm trying to think of an excuse to end the stream early because I'm feeling extremely nauseated. Probably TMI, but I'm going through some withdrawals from some prescriptions. But anyway, less said about that, the better. So this comes around here into AND gate. So if that side is switched, this is currently the wrong way round. So how does this work again? How on earth does this work? So AND gate. So if that side is switched on, it switches. That's how it works. Yes. So you go. Something like this. Now, if this side is except yes, you want the reverse of this, so you want no, that works. That's fine. Exactly right. Bit of a clunky AND gate, but no, I've mostly been going with that as the AND gates for this whole build. There is there's a slightly more efficient way of doing it that I know of. Also, I am avoiding using advanced Minecraft techniques like instant logic gates because it takes away the fun of it, and I'm not supposed to know how to do that kind of thing. The only concession being the instant wires. That's obviously a fairly simple glitch. So Yes, this plumbs into here, which plumbs into this guy. Also needs to plumb into the switch here. Let's just test it. Switch that on. That switches on. Repeater here. Classic taxi cab paradox. I guess what I can do is I can loop in a switch from here. That's what I can do. Save putting 2 towers in. In fact, I don't even need to, do I? Yeah, no, I don't need to. This tower just works fine for that purpose anyway. Means that this could be an instant wire. If I can remember how to make one. Oh, that's right, mossy blocks don't work for instant wires, do they? So I need redstone block. I need to get rid of the mossy block. What are these? I believe it's like this. Oh god, I need to look this up. Right, so it's like that, yes. So in fact it is red wall. Red wall. And that now reaches to not the top. Well, isn't that irritating? Ah, that's why. Copy paste error. Now that reaches the top. Excellent. Hopefully this reaches. That should be fair. I can just put an infinite number of instant wires there, so it should be absolutely fine. But I guess I'm standardizing it like this now. Right. So that largely covers that productive session so far. As I said, I am feeling quite nauseous, so I think I will end it here. No point in torturing myself. I mean, it's basically a combination of. I mean, Minecraft gives me a bit of dizziness and nausea at best of times, but yes. Look how cool this binary multiplication unit is, though. That's a neat circuit. Proud of that. I mean, it's as slow as sin, but and this whole thing is like a 30 seconds of processing time, I think. But actually, it might be more like a minute. I'm not sure. I think it would only be 30 seconds. I mean, it will be one of the slowest logical operations in the computer. As I said, I don't know a better way of doing it than this. There might be one, but I'm supposed to be doing this as much off my own knowledge as possible. So, yeah.